In this video, we're looking at section 2.1. Section 2.1 is looking at proportions and similar figures. A proportion is an equation containing two equal fractions. So if A and B and C and D are those ratios or fractions that are equal in value, then the equation A over B is equal to C over D. It is a proportion where B and D, or the denominators, cannot equal 0. This proportion can be read as A is to B as C is to D. A proportion can be proven true by cross multiplying. For example, 3/4 is equal to 12/16 because 3 times 16 equals 4 times 12, or 48 equals 48. So if we reduced 12/16, we would get 3/4. 5/4 is not equal to 10/16 because 5 times 16 is not equal to 4 times 10, or 80 is not equal to 40. And if we tried to reduce 10/16, we would get 5/8, not 5/4. So here's a couple examples. We first have 8 over 18, and we need to know if that is equal to 4/9. So, as we're seeing, instead of reducing them to the lowest terms to see if they're matching, a quicker way might be to cross multiply. So, 8 times 9 will be the same as 18 times 4 if this proportion is true. And 8 times 9 is 72. 18 times 4 is 72 as well. So yes, this is a true proportion. Let's check the next one. We have 9/21 is equal to 6/14. Is that true or not? Let's see. 9 times 14 will be the same amount as 6 times 21. And if that's true, then it is a proportion. So let's look at a math. 9 times 14 is 126. And 6 times 21 is also 126. So yes, this is another true proportion. Sometimes in a proportion, you're giving a missing value. So any missing numbers in the proportion can be found by using cross multiplying. So let's solve these two examples for x. And I always go across the two that are across from each other where the unknown value x is. So 10 times x needs to be the same amount as 9 times -5. And you may have noticed that it doesn't matter the order. We can do 10 times x first, or you can write it as x times 10, and then 9 times -5, or -5 times 9, as long as you are getting the cross multiplication shown. And so our next step will be to simplify the two numbers that can multiply together. 10 times x stays the same, and 9 times 5 is 45. The 5 is negative, so our answer needs to stay negative. And so 10 times something is equal to 45. To find out what that something is, or our x, we will divide both sides by that coefficient, or that front number of x. So we're dividing by 10. And -45 divided by 10 is -4.5. So x is equal to -4.5 to make this a true proportion. And you can always plug it in is x and cross multiply to make sure that you get the same number. Let's take a look at B now. We have 55 across from x, so 55 times x, or 55x, needs to be the same value as 8.8 times 1.5. And so again, we will multiply on the right-hand side to simplify it. So 5 times x should equal the same amount as 13.2. And then when we divide the coefficient of x to get it by itself, we'll divide both sides by 5. We see that the x value needs to equal 0.24 or 24 hundredths. Let's take a look at some more examples. 10 is to negative 6 as x is to negative 15. So the negative 6 is across from the x, and that should be the same amount as 10 times negative 15. And so negative 6 times x should equal negative 150, doing our multiplication there. And then our last step is to divide both sides by the negative 6 to get rid of the multiplication. And here, x is equal to 25. Notice it's positive because we had a negative divided by a negative. Our next one gives us fractions to deal with. Actually, fractions aren't too bad in proportion since we're just multiplying and dividing them, so we never need a common denominator. So that is really nice. So our 3/8 is the fraction that's getting multiplied to our x, and that should be the same as 9/2 times 1/6. So 3/8 x is equal to 9/12. If we multiply straight across, we can simplify it. Let's divide 3 into 9, which gives us 3 left. 3 into 6 is 2 times, so we have 2 left. 3 times 1 across the top is 3. 2 times 2 is 4 across the bottom. Oh, I forgot my x over here. So 3/8 x is the same as 3/4. Remember, to get rid of our fraction, we're going to flip it and multiply. So we're going to multiply by 8/3 to both sides times 8/3. So divide by 8, multiply by 8, cancel. Same thing with the 3s. So we're left with x on the left. And notice the 3's cancel here. And 8/4 gives us 2. Here's some more problems with fractions. Notice we have some mixed numbers, so when we rewrite it, let's go ahead and put those mixed numbers into improper fractions. So our 1 and 1/6 is across from x. 1 and 1/6 is the same as 7/6. And across the other way, we have negative 5 and 1/4. Remember, ignore the negative sign when you're doing the math for the multiplication and addition for your numerator. So 4 times 5 is 20, plus 1 is 21. So we have 21/4, and then make it negative. And that's getting multiplied by 2.5, which is 5/2. We can't simplify there, so we'll just go ahead and multiply. So we have 7/6x. And that is the same as negative 105/8. So again, we'll divide off the 7/6 to both sides by flipping it and multiplying it by 6/7. And again, you can multiply straight across and then simplify, or you can start simplifying first. I see that 7 can go into 105, so 7 divided by 7 is 1. 105 divided by 7 is 15. And 6 and 8 are both even, so let's divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So we have 15 times 3, which is 45 across the top, and 4 times 1, which is 4 across the bottom. And I did not forget about this negative sign here. 1 negative stays in the answer. So x equals negative 45 fourths, or if you want to write it as negative 11 and 1/4, you can do that as well, as you know. Our next question, we have x over 10 is equal to 3/5 over 4. So cross multiplying, we get 4 times x is equal to 3/5 times 10. And let's put that 10 over 1 so we can see it as a fraction. And notice now 5 and 10 can be simplified. 5 goes into 5 once and goes into 10 twice. So we're left with 4 times x equals 6 over 1, or just 6. And then let's divide both sides by our 4. And we get x equals 6 over 4, which reduces down to 3 over 2. Figures that are the same size and same shape are called congruent. What this means is that all sides and angles are equal with respect to each other, so it's a carbon copy. However, figures that are the same shape but not the same size are called similar. Similar figures have all sides in proportion with respect to each other, so it's like enlarging it or shrinking it in proportion. So for example 3, we have similar triangles. Find the measure of x. So when they're similar, we can use proportions. Notice we know what all 3 sides are. And so we need to make sure that we use the unknown side and its pair in our proportion, but we can use either, in this case, the upper left-hand side pair or the bottom pair. I'm going to use the bottom pair since it doesn't include a decimal. Seems easier. So those are the 2 pairs of numbers that I'm going to use. So make sure when we set up a proportion, we're setting it up in the same pattern. So I'm going to do the right side is to the bottom as the right side is to the bottom. So 10 is to 16 as x is to 24. And then we can multiply across to get 16 times our x is the same value as 10 times 24, or 16x equals 240 when we multiply. And then we need to divide both sides by 16 to figure out what that x value is. So here x is equal to 15 feet. Notice I put my label on there from my problem. Here we have similar triangles. We have a 7, 7, and 11, x, 14, and 22. So again, we need to make sure that we have this left side in our proportion because that has the x. But then we get to pick another one. And so I'm going to use the side that matches. Since 7 on the left matches with 7 on the right, then these two have to match because they're in proportion. So 7 over 7 has to equal x over 14. So we don't even have to do the math since those two match. The other two have to match. So x is equal to 14 inches. Nice, easy one. So even though in this case we have inches in one triangle and inches in another, it doesn't matter when we set up the proportion, again, as long as we're consistent. There's no need to convert inches to feet if one's in inches and one's in feet, but again, make sure that you're setting up your proportion in the same pattern. Here's another example where our scenario deals with trees. A tree casts a 65-foot shadow, while a nearby tree that is 11 feet tall casts a 5-foot shadow. And so how tall is a tree? So our unknown, I guess I should be easier to see color over here. Our unknown value x is the height of the first tree. So let's do height is to shadow as height is to shadow. And now we have a proportion that we can solve. So we have our 5 being across from our x, and that's the same as 11 times 65. And so 5x is equal to 715 when we multiply. And dividing off the 5 tells us that our value of x, which represents the height of that taller tree, is 143 feet tall. So in the next problem, we're going to see that sometimes we are going to be given a proportion with a story problem, but without a picture. Okay, 2 more examples before I let you loose to try them on your own. Here's the examples that don't have a picture, but we're still using a proportion. If lemonade needs 3½ lemons to make 16 ounces, how many lemons do I need to make 36 ounces? So if we use our proportion just the way they come in order, we have 3½ is to 16 ounces as how many lemons? So that was our numerator, so we'll put our x on top, is to 36 ounces of lemonade. So there's our proportion that we can solve. 16 times x is the same as 3½, which is 7/2 times 36. To solve, let's go ahead and drop down our 16x. And our 7/2 times 36, well, 36 is divisible by 2. It's 18 times 2 to get to 36. And so all we need to do is 7 times 18, and that will give us 126. And then we'll divide the 16 off of both sides to get x by itself. And so we have x equals 126 over 16, which simplifies down to 63 over 8. And if we change that to a mixed number, since we usually don't refer to lemons like that, we would say that that is 7 and 7/8 lemons. So almost, I would use 8 whole lemons, but according to the recipe, 7 and 7/8. I like my lemonade puckery. Last example, here we have 30 teenagers. So let's do 30 teenagers is to 72 slices of pizza. How many slices of pizza? Oh, so that's our denominator, because 72 slices of pizza are needed to feed 120 teenagers. So again, we have teenagers is to slices, as teenagers is to slices. Make sure you set your proportion up appropriately. So we have 30 times our x equals 72 times 120. That's a lot of pizza. So 30 times x, when we multiply it on the right-hand side, we get 8,640. but then we have to divide it by 30 to get x by itself. And so when we do that, we see x is equal to 288. And again, that represents slices of pizza. So that are all the examples that I have for you right now for proportions and similar figures. So now go ahead and get started on the practice problems for this section on pages 52, 53, and a couple on 54. If you have any problems with them, don't hesitate to ask. Otherwise, I'll see you next time.